In this next lesson of our advanced refrigeration, we're going to be talking about compressor capacity control. Now, I mentioned this a little bit in lesson 4, but as we were talking about special components, but we need to go into it a little bit more just to give a little bit of a better understanding. So, this is a relatively short lesson, but it contains some important things. Okay, so we need to use capacity control on any system where load varies over a wide range. For example, air conditioning that has to run year round. Our compressors are obviously going to be needing to do more work in the summer months than in the winter months. We also use these very heavily in refrigerated storage where product moves in and out rapidly. In other words, think about a situation where we're processing, for lack of better example, say oranges or meat. You have heavy product moving in, which is very warm, and then as it cools down, I have to use less and less refrigeration to maintain that product, and it moves out very rapidly, and then all of a sudden I get a whole bunch of new warm product in. So capacity control through the compressor is in its simplest form on-off operation of the compressor. But in larger systems, it's unacceptable to turn this on and off because of fluctuations in the controlled temperatures and short cycling. Short periods of on time is not good for compressors. They have to run as long as they can in a stable condition. The other thing you have to be aware of, in very heavy environments and in commercial environments, power is billed at the peak. In other words, the high amperage conditions of power. So as a compressor starts, we pull a lot of power into the compressor, okay, for our locked rotor amperage. So that is the power that is the billing. So the customer, the more often the compressor comes on and off, the higher your billing is going to be for the customer. In light load conditions, okay, we could result in compressor short cycling. So Copeland is one of our compressor compressor manufacturers. It uses either internal or external unloading. So internal capacity control valves, okay, is a valve inside the compressor that is energized by a solenoid coil, which causes the needle valve to become unseated at the lower port. It allows the suction port for the cylinder to become unloaded. The cylinder pumps down to a vacuum until no more pumping action occurs. What this does, it reduces the capacity of the compressor based on that cylinder. So this is just an example of a solenoid coil that you find on the outside of the system. It has a needle valve inside of it. Okay, it has a port to the discharge pressure and a port to the suction pressure. And all it does is seals off one of the ports in the compressor when it's closed, and that reduces the amount of refrigerants that's pulled through the compressor. External capacity controls are also found on Copeland systems. Okay, they're found mostly on 3-cylinder compressor. The valve is a solenoid operated external bypass valve. What the bypass valve energized, and it isolates the cylinder from the discharge pressure. The valve connects the discharge ports of the unloaded cylinder to the suction chamber. In other words, all we do is allow the suction pressure to be on both sides of the cylinder. Okay, this type of unloading is recommended for high temperature applications because of the compressor's overheating. Okay. External capacity control valve, again, all it is a bypass. It bypasses the discharge from the compressor cylinder back to the suction side when it's energized. Now, Carlyle is a carrier product. Okay, Carlyle employs a mechanical or electrical system to unload the compressor based on suction pressure. On a mechanical unloader, as the suction pressure drops, the unloader piston assembly is moved to where the gas is bypassed into the crankcase. Okay, all it does is take the discharge high pressure gas from the cylinder and puts it directly back to the low pressure side. So again, less refrigerant moving through the rest of the system. Okay, basically no pumping occurs, reducing capacity. These compressors are shipped unloaded and must be set on startup. This is an example of the Carlyle or carrier unloading. You see these on semi-hermetic compressors. You don't see them on fully sealed hermetic systems. Okay, when they're loaded, our entire system from all cylinders goes out the discharge. When they're unloaded, two or more of the cylinders will bypass directly back to the crankcase and not go out the discharge. They also use another form of this called electromechanical unloading. Electromechanical unloading has a small external solenoid that's controlled by an external controller which loads and unloads the compressors. The suction pressure drops, the controller energizes the solenoid, moving the unloader piston assembly so gas can bypass into the crankcase. In all of these unloading and loading sequences, as the pressure drops, outside temperature drops, load drops, or whatever's causing the pressure to drop, one or more of the cylinders gets bypassed straight back to the crankcase or the suction line. This is just an example of the electromechanical unloaders. You'll see the solenoid over here on the system. That's external and can be changed out if needed. Hot gas bypass control. Okay, it is very close to, but don't confuse it with low ambient hot gas bypass. It's used to false load the system under a low load condition. The applications include ripening rooms for produce where the load varies dramatically from hour to hour, or AC systems that must run 24/7, 365. The false load can be applied to the compressor or the evaporator depending on the application. An example of this is a refrigeration system that's operating at 30 degrees Fahrenheit evaporator and a compressor capacity with 20 tons against a system load of 15 tons. In other words, I have 5 extra tons of cooling. To balance the load between the compressor and the system, 5 tons must be bypassed. So what happens here is the hot gas is bypassed to the evaporator. Okay, you see a hot gas line solenoid, hot gas bypass valve. We open the solenoid and we send hot gas directly to the evaporator, which reduces the capacity of the evaporator by whatever this is set to. With hot gas bypassed into the suction line, a liquid injection valve is used to de-superheat the discharge gas to protect the compressor. So again, we do not want to overheat the compressor either. Okay, so we have to do a bypass valve as well to protect the compressor. So that's unloading a system or compressor capacity control. Bottom line is we either shut off a cylinder using the first method, we bypass cylinders using the majority method, or we bypass hot gas directly to the evaporator to create an artificial load on that evaporator. Because again, we do not want the compressor to ever get liquid back into it. That's what we're basically protecting against. And we don't want to short cycle systems.